Hello everyone, welcome to 56, I think, Makercast. I'm Radan and we have a very nice selection of guests today. I will let them introduce themselves. Maybe I will call each of you and then you can say something about... Okay, Moritz, you are already
I will start.
first.
I'm a software developer, mostly in my daytime job, but my hobby stuff is electronics and such, and also programming. And I'm also a maker and do a lot of crazy things. That's the short introduction.
Okay, next, psychogenic.
Hey, psychogenic, aka Pat. I'm by day a maker of machines and things, and by hobby a maker of machines and things. And that's pretty much it. I work a lot on lately on open source stuff, ASIC stuff, and things like that. That's pretty much it.
Okay, Jacqueline.
Yo, that's me. Hi, I'm Jackie. Gosh, I don't know how to describe myself succinctly anymore. I used to be a software engineer. Now I make various of things. Yeah, that's me.
Okay, thank you. Looney.
Hello, I'm bitluni and I'm an influencer.
An internet micro celebrity.
I do electronic stuff on YouTube. That's my day job.
And Bradan, did you fix your sound already?
The face is mute.
So spooky.
Type your introduction. Oh, still no audio. He says in chat.
All right, we will get back.
Oh, I was muted as well. Sorry. So we will let Bradan introduce himself when it's his turn to present. Hopefully, it will be fixed by then. So, what order do we want to go? Maybe the same order we went with the introductions. This way there will be no surprises.
My cat has also just sat exactly where my downwards camera is. So the longer we put off me, the more chance it is I can actually show you things.
Okay, then you can go just before Bradan. One to last. Okay, so Moritz, you're on.
We all got problems today, I think.
Computers.
I actually got 3 projects to show, so I will do it very quickly because time is short. So the first one is actually something by Google. They did a design study on non-intrusive smart home devices. And you can check it out on their website, littlesignals.withgoogle.com. And they essentially designed a few different devices for your smart home that interact with your home, for example, with air, which blows on a plant to notify you about something. And they got all these different things that they just designed. So there are not real products. You can't buy them. But
Can you go back to the button one?
This one? No.
No, it was like one back.
That one.
Yeah, there.
Yeah.
Great.
So that's something the button can raise and lower itself to notify you, and you can push on it to interact with it. And the one that I found interesting was this movement one, because it actually makes a great bar graph display as well as a notification central. So if one of these pins moves out, then that could be a notification of some sort. And then if you push it back in, then you're done with your task, for example. And I actually did a little bit of prototyping. So I 3D printed a few things And I thought it was a good opportunity to do a first project with these micro servos. And essentially what I did is just, so this is a parametric design, so you can do it with one or more of these pins. And the first idea that I had was to use a cam, but that didn't work out that well because the space is so limited in here that you don't get enough up and down movement with the servo. And since I also wanted to be able to get feedback on the position, I needed a different way, because if it's on a cam, you can't push it down that easily. So I thought a gear and a sprocket, I guess, is a better solution. So this is one project. I really wanted to show something, but it's not in a working state right now. But essentially, the servo goes in here and then engages with the sprocket and then can technically move it out and in. And that's the first one. Then the second project, I also got inspiration from the internet. I don't know if you have seen this Kickstarter project, or it was at least a Kickstarter project. This is a solar light which charges obviously with solar energy. So you have these solar panels that are on one side of the device. Let's see here. You have these solar panels, a battery, and then a light strip, a housing, and then a diffused frosted panel. And I really thought this was a cool idea, but when I looked at the price, I thought to myself, I can pretty much do it myself for a lot cheaper than that.
What is the price? I'm so curious.
The price is like 200 euros or something or more. So what I did was I designed. First of all, I got a few solar panels. Let me switch the camera again. I got these solar panels here, quite big, 5-volt solar panels. I think 5 watts as well. So I have a few of these, and I started with designing the overall shape, starting from the size of the solar panel, which slot right in the back here. I had to do the part in 3 separate parts because they don't fit on the 3D printer that easily. So I just made this mechanism or thing where you can just slot them into each other. So you print these 3 parts, then push them together and you're done. And for the frosted panel, I just got some laser cut acrylic, or plexiglass it's called. And yeah, that goes right in the front. I need to still work on the electronics. What's also interesting about the Sonne thing, that they actually, if you look at the Kickstarter project, they use Adafruit products for their first prototype, which I find very interesting. And yeah, I will probably also use the Adafruit solar charger PCB in conjunction with an SK something LED strip, which can do warm white and colored. And then that's the idea here. But I started with the 3D design first to see how it looks and feels. And what was also funny, I had to buy a few more of these laser cut things because it actually didn't change the price. They had a minimum price that you had to pay, and so I got 3 of them. So
where did you order?
Oh, these they are from. I will look it up and tell you later.
Okay.
But I can figure that out. I don't know right now.
Yeah, I thought like a major fab house or something that you can basically.
Yeah, it's probably something like lasercut24.de or something.
Oh, okay.
But I will look it up and tell you.
Okay,
and
nice.
Then for the last project, probably some of you know that Open ePaper link. This is actually my access point here with all the tags. And if you don't know the project, it's by Aaron and some other awesome people who reverse engineered these microcontrollers in these e-paper price tags. Yeah, it charges on one side and glows on the other. That's correct. And the idea with the light is that it charges during the day and then lights up during the night or evening your house. With these e-paper price tags, you can put a custom software on there, and then you can display anything you want on it. You have a Home Assistant integration and everything. There are different sizes of e-papers. I also got a really large one, which I don't have here right now, but there are actually quite a few different ones. These also have buttons that are integrated and also into Home Assistant, so you can press it here and then do something with it. But the project that I had in mind was, my initial project was to make a smart room sensor, which I probably showed before. And there I made a custom PCB using ESP32. These are actually two versions because I wanted to be able to have it run on a battery for like a year or something, so you don't have to recharge it. But it didn't work out quite in the first version. And the second one with these, I use these e-cigarette batteries because you can find them literally littered everywhere. So that's also a quite good source for batteries for these kind of projects. And with one of these small 360 milliampere hour batteries, I had the first PCB, I think, last for 2 weeks or something, and the newer one, which with improved battery design, for a month or something, which is not great, but there are things to still improve. But then I actually went a different route, since these e-paper price tags, they already have a microcontroller on there and everything that you need to display everything, because they are also already designed for low power application, because they put in 2 batteries and then probably throw it away once the batteries are empty, and they really last a long time. So my idea was to do some energy harvesting with solar panels, but that actually didn't work out quite that well. So I got some perovskite or amorphous solar panels, which are quite good for indoor use and low light conditions. But the caveat is that they only produce like a microwatt or something of energy, which is very tiny amount. I also got some different ones that do a little bit more, like 10 microwatts or something. But actually these normal silicon solar panels here outperform these in low light conditions, at least in my tests. But it wasn't enough to be able to sustain a charge or charge the supercapacitor here, because I made a small PCB for energy harvesting. And there are actually 2 designs, one with voltage monitors, which didn't work out at all, because once the voltage level was reached and it turned on the output, then the voltage drop turned it off again. So it was just turning on and off all the time. So that design was bad. Then I had another design with a boost converter from the solar panel going into another buck boost converter for the 2.5 volt output for the display. That worked better, but as I said, the circuit alone without the e-paper price tag already uses 100 microamps, which sounds not that much, but for energy harvesting, it's so much that it just drains the supercap. And the only way to charge it up and provide enough energy is like in direct sunlight. So I literally wanted to get some dye synthesized solar panels, but they were just too expensive. That's like the new hot stuff for indoor applications and such, which would be really nice to test with this. But also I probably need to redesign the circuit to use less than 100 microamps, because it's just too much, because in a low light condition you only get like 2 or 3 microamps, and that's it. So yeah, that project was maybe a waste of time, but I will have to see. I would really like to get some help on that. If you know a thing
I
or
have some
two.
ideas, actually. Were you using a chip that uses maximum PowerPoint tracking? The EP's chips are pretty hot. I've been playing with a lot of that lately, and we're down to, you have to be above 200 lux, say. So in terms of illumination, but a room is 300, 500, 700, depends. But the point is, you need to do MPP tracking, otherwise you're going to suck the juice out of it and it's just going to crash. So if you're getting out the right amount of juice, I characterize these things, and I could get, with the best ones I had, which weren't that great, about 0.16 microwatts per centimeter squared per lux. So in essence, I could get a few hundred microwatts in bright illumination, but otherwise, less, but still indoors. And I'm curious which solar cells you're using. I'd like to know more about that, because I need to characterize these things. I just got some random Panasonics and they weren't great, but the EP's chips are really good. It's a Belgian company.
Yeah, I will have to look that up, because I'm also guessing the first boost converter already states in as a quiescent current that it's 20 microamps. So that's already a lot.
Yeah, that's too much.
And the second one uses 2 or something, but I don't. Also, I think the supercaps that I'm using are just garbage, because they probably
if they're
draw,
leaky,
leak too much of current. So yeah, the whole thing probably needs to be redesigned. So I'm probably either going to go back to the own PCB, but I would really like to have this working, because you can reuse the whole hardware without having to throw it away. And it's probably maybe easier to get it working with that than with the ESP32, because the ESP32 is very power hungry compared to the 8051 or whatever microcontrollers on here. But yeah, that sums it up, and I already probably spoke too long. Or 15 minutes. Okay, I guess it's
No,
fine.
you are good. No worries.
Yeah.
Okay, so you are finished. Thank you very much. Very interesting. And yeah, I think asking for help on Makercast is also a great way of getting the audience engaged. We need that engagement. By the way, click the subscribe and like and all that.
You gotta play that little GIF everyone has of like clicking on the little button.
Press the button up here.
Right. I think Mr. Duck is next.
Oh, it's me. How am I? All right. Well, hello. Okay, so this is about KiCad. You know that the KiCad layout has a scripting engine that's really awesome, and because of that, we have a bunch of plugins. But what I was missing was something for the schematics. I want to be able to script and play with schematics. So I just released this thing, which is Skip. So it's an S-expression KiCad Python parser. And so the files look like this. The layout and the, I'm just showing my face, aren't I? Hold on a second. So the layouts, the layout files and the schematic files look like this. It's S-expressions. It's great if you have the Lisp, but if you don't understand parentheses, it's really not that fun to parse. So I created this library. So in essence, let's take a look at it. So what I do is import the library and then bring in a schematic. And so I'm just going to take this file. And the schematic we're looking at is this one here. So it's just the tiny tape out demo boards. So not trivial, but not the most complicated thing, but it'll be enough to play. So this is the file I just loaded. So in the schematic, let's see, what do we have? We have simple things. There's a bunch of elements in here. So if you look at paper, it's just a simple attribute in there. So it has a value which you can set. Let's call it A4. And then if I just look at the paper again, now it's A4. Okay. So that's semi-interesting. There are also things that there are multiples of, so collections. So one of these would be, let's see, the labels. If there's labels in here, you'll have one of these. There's text. There's a whole bunch of stuff. And each one of these can be treated as, at a minimum, as an array. So wire 22, okay? So in that case, you can just go loop over it just like an array. So in wire. So there's all my wires. Great. The same thing with text. So everything can be an array like this. These things have multiple attributes. So, you know, they have a position, and all these names are derived from the file itself. I don't engineer most of these things. So here's the text value. You can see that, right? Let's see. Where are you? Yeah. Yes. Okay. So that's collections. Now, the most interesting collections are the ones with names. So if you look at the symbols, this is a huge collection. And the fact is that it works the same way as a list, but it also works with attribute names. So you can go whatever. The lib symbols is similar, but you probably don't want to play with that, but it has memory flash, stuff like that.
Your prompt is hidden behind your name tag. We can't actually see what you type.
Okay, hold on a second.
Can you zoom in? Yeah.
Here, you can't see my cursor here?
No. It's
Okay. Let me. How
yeah.
about that?
Move the window. Yeah. Thanks.
Okay. Good. Thank you. So let's see. So we can get any of the schematic symbols that are in there by going schematic symbol, you know, let's give it a name, J15. So, okay, that's my connector. So each symbol has attributes of various kinds, depending on what's in there, in the BOM, in the DNP, and you can set those as well. I can say in BOM.value equals false, and then I can use it like a normal KiCad Boolean in BOM, then con.dnp equals true, dot value. Yeah. So con.dnp. Okay, cool. Now, the important thing with these guys is that they have properties. All the symbols have these property things, which is also a collection. And so you can go for P in con property, and it'll give you these things. You can all obviously edit them. So the data sheet and the code completion works here. So that's really neat. You know, you can see everything. Value equals ho.pdf. Look at it again. And okay, so that's the basic manipulation. You can do all the raw stuff, but there's also some neat functions here for just utilities, basically. If I go R13, I can see everything that's been attached to it. So if we look at the schematic, R13, wherever that is, R13. So this guy has a cap, a switch, and a resistor. Well, yeah, cap and switch and resistor, and you can play with all of those. So you have everything that's attached, basically the wires, the symbols.
Are those attachments mutable?
Pardon?
Are those attachments mutable, or is it not that magic?
I'm sorry, I didn't hear that.
Like, if you like the attachments, can you like go and like modify those and it?
Oh yeah. Well, that's it. So let's
so
do
sick.
some of that. So here's, let's say switch. Where's switch 4? This guy. Yeah. Okay. So let's play with this guy. I'm going to take. So what you can do, because creating these things, they go really super deep and it's kind of annoying. So what you can do is clone them basically. So for a label in schematic symbol, switch 4, attach global labels. I'm going to go label clone. So now I've got a copy of it. I'm going to change it because I like to have, see, they're pointing in the right way. The inputs go this way. Well, in this other thing I'm going to make, I want them to go the other way. So I'll say they're inputs, and I will move them installation by 10. Now that's done. So let's also do something else. Let's go the symbols that are attached. Let's see. Schematic symbol switch for attach symbols. That'll be all those resistors. So if I go for S in these guys, I'll also clone these guys. I'll translate them. Translation -20, say.
Translation.
And then
Oh,
finally
no.
see the property.
You translated them.
Pardon?
You translated them.
Yeah, that's it. I just shifted them over. You have a move and a
No,
translate.
you didn't translate them. You
You
translated them.
translated them.
Oh no. Okay. Let's do it the right way. So I'm going to have a bunch of them now. Yeah. See clone. See translation. Boop. And finally, what did I want to do last? I wanted to set the value. 20K. Boop. Okay. Well, so it's going to get messy, but let's save the schematic. Overwrite. You've got to write, of course, but anyways, I'm just going to overwrite it so I can reload. So let's reload this mess. Open recent. Pop. And here we go. The ones I copied over. The labels flipped. Anyways, you can do pretty much anything. The point is, it's finally has the power, I think, of the PCB stuff, because it's super cool to script on your own or with the plugins, and now you can do it with the schematics too. You can also do it with the layout with this system, because it's basically the same kind of file, and all those attributes are generated dynamically. So if you have symbol.j15, that I didn't know that, I got it from the file, so it just does that pretty much automatically. It's on GitHub now. I'll post a link somewhere. Maybe in the comments here. But yeah, I would appreciate any kind of feedback on that. Yeah, that's pretty much it. Can I post a link here? I'm going to try. Yeah,
if not, you can post it in the private chat and I can post it.
Okay, here you go. That's pretty much it. Questions?
Thank you very much. Yeah, I can post the link. Next up, who was next? It was Looney or Jacqueline. Jacqueline.
Yeah, I can go. Chungo has moved.
Okay, go ahead.
Hello.
Hello.
I am primarily here to spruik Tangara, now available on Crowd Supply. Not available, but I'll send you one eventually if you pay me. But I figured, since it's my first time and I can show off many things, I would show off some of my other things real quick first, such as some of my M&T toys. So, for example, here is my Reform that I built. It has a Lily 58 instead of the regular Reform keyboard. It's got a trackball. This is all the CNCing I got someone else to do because I'm not set up to CNC myself, but otherwise I built all of this except for the hinges I had to get from M&T. But otherwise, this is all me, all hand soldered.
Crazy.
And I also replaced the regular Reform has a barrel jack, and I built this one with USB-C power delivery on the side there.
Nice.
The reason why this is in pieces at the moment is I have this very, very shiny, beautiful thing from M&T, which unfortunately I did not build myself because this is like a 12-layer board with buried vias and stuff, but this is the open hardware SOM for the Reform, which my little side thing at the moment is trying to convince that to boot from its internal MMC so I can run it without an SD card. And then that's my dream, to have my laptop running, the laptop is open hardware. Yeah, the LSA module. Yeah, that's the one. So I want, the motherboard open hardware, the actual processor all open hardware, 99% blob free. It's really cool. I love this little project. So that's my kind of very impressive showpiece I bring out because it's cool. But as I say, my beloved little MP3 player is the thing that I mostly want to talk about. So this is, if you're not familiar, I will spare you reading all of the campaign page verbatim directly down the camera. You can go have a look at that yourself. But basically, this is it's an MP3 player. It has an ESP32. It's got a nice big internal battery. Yay, it does turn on. It's got, physical hardware, volume buttons, lock switch, TRS jack, USB-C port, and we have a nice full-size SD card as well that I will hold up so you can see. It's all open hardware. You can back it, and I'll make you one. You can also just build one yourself. And I thought what might be a nice way to show it off is, let me switch to this one. So I've got two with me. This is our most recent case design, which you can see it's a little bit narrower, a little bit smaller. We've also changed some other things, like the buttons are easier to manufacture, the touch wheel cover is a little bit thinner, which just helps the sensitivity a little bit. Lots of little kind of design for manufacturing changes, but I'll show you what's inside this one because it comes apart a little bit easier because the tolerances aren't quite so tight. Let's see, what to say about it while I'm taking it apart? I don't know. Does anyone have any questions? Does it do rickrolls? It could. It's very possible. So it's powered by an ESP32, which I will show you right here. That's our main kind of application processor. So it does Bluetooth. In theory, it does Wi-Fi. Our firmware doesn't do anything with the Wi-Fi yet. Bluetooth as well. I gotta fix some bugs, but it's basically working. We use a standard 3-pin LiPo pouch. Chungus, don't take my screws. It's 2 boards, as you can see. We've got a very cheap little display. It displays full colors quite nicely, actually. I'm quite happy with the colors of the display. I do not have the UI design skills to make use of the colors well, but it's all right for a $2 display. We also have, you can see we have a very cool capacitive wheel here. It's a little bit different. It looks in many ways like the old iPod click wheel. It's actually a fair bit nicer to use. Because if I bring over an old iPod one here, you can see we've got a little bit more of an area. Ours is a bit more sensitive, and crucially, we also have a little haptic motor here, so you can get some feedback. Makes it pretty nice to use. And then, if I take the back, what's doing the touch sensing? So it's basically a microchip Q-Touch peripheral. We've got a dedicated, I don't know the product number off the top of my head, but it's a dedicated little IC that does a Q-Touch wheel. Yeah, exactly. You don't want too many colors. And, I don't know. Mostly what you want colors for is, album art, but I don't know. It's always seemed like a extra thing rather than something you need to me. The touch wheel, by the way, I should spruik my partner's work. All the parameters to generate these is kind of complicated, and there's a bunch of different libraries for things that aren't KiCad. We don't know enough about how to do KiCad scripting to make a nice library for that, but we do have a nice little SVG generator so that you can put in how many different electrodes you want, what kind of spoke widths you want, all that kind of stuff, and it'll just spit out an SVG for a wheel like this with a... I forget if we included the electrode in the center, but it's easy to add. So it's all pretty easy to make your own kind of custom wheel type thing. And here we have the actual main board with the stuff on the bottom, and you can see, so like I said, it's an ESP32 for the main application processor, but we've also got a SAM21 down here that does the USB-C port, because if you're familiar with the ESP32 line, this one, the main the one that's just called an ESP32 does not have a USB peripheral. So a lot of dev boards and stuff you'll see put in a generic, a CH, CH234 or whatever, USB to UART converter. We've got a full-on microcontroller here, which not only can do the USB UART bridge so that you can flash, debug, do anything you want just over USB, but we can also, I'm working on mass storage so that you can sync to the SD card over USB as well. Are there just 3 electrodes in that touch pool? Yes. There are only 3, and like you can see, like you don't actually need much more than 3, it turns out. We're going to write for our crowdfund. We've got a bunch of weekly updates planned. The one that's going to be out this week, we're talking all about the design of this, going into a lot of detail if you're curious. But yeah, basically you don't actually need a lot of electrodes. The iPod click wheel, for example, has got, I want to say it's like 20 or something, because they're all these little rectangles, but if you make them kind of overlapping like this, you can basically just interpolate where it is, and all you need to consider is that there will be a small dead zone between, you know, where they don't overlap, but so long as you keep that dead zone smaller than the width of a finger, which, you know, is true even for my smallest finger, it's not like a perceivable dead zone. It's actually fine. Yeah. I don't know what else to say. It has everything you would want an MP3 player to have. A DAC, an amplifier. They are 2 separate components so that if you are audio inclined, you can mess about with this. So for example, I use really sensitive IEMs. So this, the way we're producing it, is set up for like really low sensitivity, like your big hi-fi headphones, like the ones I'm wearing right now, like these ones, like DT770s. But if you use little IEMs, there can be a little bit too present of a noise floor here, so it's pretty easy to just hack this together to lower that down. We got full-on, like, you know, battery charging, system load sharing. Yeah, any questions? I've been swimming in Tangara for so long that I don't know which bits are interesting anymore, because...
I have a question. How do you put files on it?
How do you put files on it? So at the moment, it's just, you know, you put the files on an SD card, but I'm working on USB mass storage support, because basically we've got a little mux here that switches so we use the SD card in SPI mode, and this is basically just switching whether it's connected to the SAM21 or the ESP32. So basically, in a couple of weeks, whenever I finish it, you'll be able to do file syncing via USB.
Nice. I'm asking because I know Atomic 14 on the last Makercast. He was showing work he was doing with a dedicated chip for exposing the memory.
One of our early
you didn't get
versions
very
used one
nice
of those.
transfer speeds.
Yeah, the problem I found is that they're really expensive, and also really, like, we played with a couple on early iterations of this, and they're really hard to get working.
Yeah, of course.
Versus, like, you know, just a little SAM21, maybe the transfer speed isn't as high as it would be with a more dedicated... I don't know, we get, like, full speed USB too. Yeah, and the SPI bus to the SD card is running at, I think it's about 20 megahertz, so it's okay. It's good enough for, like, light file management.
What's the notch next to the ESP? The heart there?
This one?
The second notch.
This one?
Yeah.
That's because basically the battery, so the stack up is, you've got the bottom piece, then you've got the battery, then you've got this main board, and that's just a little place to route the cable for the battery.
Yeah, okay. I'm wondering about the little stub. If you got rid of it, the antenna might be happier.
Oh, yeah, I got to get rid of that too. There's no copper in there in the current revision, so it's sort of mostly fine. But, yeah, I think I'll get rid of that too, just because it's a little bit nicer finish. This is a slightly older revision, so we've made a few changes since here that are in this one. Like, we're using some mid-mount buttons now that are a bit more durable. The advantage of working on this thing for over a year is that, like, we've had a bunch of different prototype iterations. Like this TRS jack has changed it a couple times to get one that we're happy with the durability of. Same for the buttons, same for the USB port. Everything's kind of.
What's the pressure force on those buttons? Do you know?
I think the most recent ones we're using is. Yeah, I don't know. It's in a data sheet somewhere.
Yeah, well, never mind. Doesn't matter.
It might be
Yeah,
50 newtons, but I don't remember.
There's a question in the chat about the certification. Yeah, I'm curious too.
We're working on it. it's
Premature logos there.
Yeah, they're speculative because I wanted to make sure all the silk training was looking about right. We do have the OSHW certification.
It's self-certified.
Non-speculative. yeah. I mean, they all are mostly self-certified anyway. But yeah, we're doing it in the next couple of weeks. It should be okay. I'm optimistic. We're not actually doing anything that's too crazy, and we've already made a bunch of changes for EMI stuff. Like we've been iterating on this faceplate connector a bit, so that. Just making sure that everything's going to be well set up for us.
Well, the ESP's pre-certified, right?
The ESP's pre-certified, yeah. But, you know.
Yeah, you have unintentional.
Yeah. It can always happen.
So
we've also got, the stack up is not ideal. That's the thing I'm most worried about for certification, because we've got, instead of 2 ground planes in the middle, we've got ground and power, because it's a 4-layer board, but as you can kind of see, it's a pretty busy routing. But yeah, we'll see. I'm optimistic, actually. It should be all right.
Can you hold it in your left hand?
In my left hand.
I mean, I'm joking, of course, about the iPhone and the placement of the antenna on the iPhone.
Oh.
The antenna?
No, one version of iPhones.
The old antenna gate.
Oh yeah. Yeah, I mean, part of the reason why we're doing a polycarb case for the crowdfund, which is very beautiful and very nice, and is not going to block RF, most importantly. Because yeah, we could do like a really fancy, nice metal case, but at the end of the day,
Right, yeah.
I worry about it. Yeah. Unexpected Maker in the comments has the, that's the main thing. They are pre-certified, but like there's 1,000 caveats. I think Slime VR ran into this as well. It might be okay. It depends on what they want to count as a wearable device. We'll see. Yeah. So you're out here knowing if there are any development boards to put ESP in and out of program with and without installed. What do you mean by that?
There are these Frogo pins. I don't know if you've heard that. It's like Pogo pins, but they are sideways.
Oh yeah, those are cool.
So you can just insert the board. But I guess that's off topic. Sorry.
Well, I don't know. I didn't come into this with a really strong plan. I just wanted to show you this cool thing I'm working on.
Right.
It's very cool.
One thing I really want to try once I get mine already is this. You can get those 3D, really transparent 3D printed things.
Yes.
So it's like in the 90s. So I'm really looking forward to try. Oh, wrong person, sorry.
Yeah, it should be cool. I mean, we're doing like a bead blasted finish, which is like pretty nice. It's a little bit transparent, but mostly it's like we wanted to make something that's sort of got nice properties that you might not be able to get with a 3D print. Like you can 3D print and get something transparent. Exactly. That's pretty straightforward, but polycarb has some really nice properties in terms of like you can work with it really easily. You can polish it up, you can paint it, you take stickers, like it's just really nice to work with. So we thought it'd be fun to give people something like that.
Yeah, I love cables. I don't use Bluetooth, so probably that won't be for me.
Yeah, that's. that's basically all I can say about our little gay iPod. I shouldn't call it an iPod. Apple, you didn't hear that. It's a little music player. Nothing to do
Portable
with
music
Apple.
player
It's a portable.
device.
It's a DAP. It's a digital audio player.
There you
I
go.
don't like the term DAP. It's very I don't know. It doesn't sound good.
It's a DAC, a digital audio companion.
Oh, there we go. Yeah, we could add the Tamagotchi thing. Maybe I can talk about the firmware a little bit as well. It does not run Rockbox. If you DM me and ask me, does this run Rockbox? I will sigh so deeply.
Does it run Doom?
It probably can. I've seen people port Doom to the ESP32. Basically, we've been writing our own firmware for this that's like a little bit more kind of modern than Rockbox. Like Rockbox, I don't know if people have had much experience with it, but it's a very old, crufty, like plain old C code base. These are the things my cat does. It's a code base in plain old C with a kind of very bespoke build system. It's got a lot of weird stuff going for it. We've been writing our own thing that's all C++ with like we're using a proper level DB for our music library. Ooh, I think I just reproed a crash. Oh,
Can
no,
you port Winamp?
maybe.
Maybe.
The thing about Winamp though is everyone wants the themes, so we wanted to make sure that we can theme this really nicely. So all of the UI is written in Lua, or just running on the device, which is, it's probably the part of the firmware that I'm most happy with because it's so easy. It feels crazy being on a microcontroller and being able to write like really expressive UI code because it's all just like this tiny little functional-ish language. It's really, really cool. The screen specs, it's like 3... Ooh. It says on our crowd supply page. I'll pull it up and read them to you. 160 by 128, and it's got 18 bits of color. So even though I am not a designer, I do not know how to use color. So it's not very colorful in this UI, but you can get a lot of color. Also, you'll see there's a wonderful kind of Moira effect with most cameras.
Yeah.
Yeah, you don't get that in person, but it's basically impossible to take a photo of.
What did you say the database was?
We're using LevelDB actually, which is really fun. It's it's Google's bespoke kind of key value store thing.
Okay.
It's written for like, big servers, right? And so in order to make it really easy to tune in production, it's got a ton of different knobs to scale it up, depending on the exact kind of hardware you're dealing with. But the trick we worked out is you can actually also scale it down with those knobs.
Mm-hmm.
So it's like, it's crazy. It's so fast. It's essentially, it's a key value store, right? So it's basically just, you're only storing keys and values, but it keeps them in a sorted order. So we're doing a ton of really fun stuff that hopefully I can show off. I think it's become unhappy because I was taking out the SD card and putting it back in when it was on to show you. But, basically, we ingest all of your music collection into our database, extracting all of the tags. And then because we're just like, we're not doing any of the sorting and collation actually in memory, right? We're just like extracting the titles of all of your music, for example, putting them all in the database, and then relying on the database to sort it for you and put it in the right order,
Right.
which lets us do these really big collated views that you can search through really, really, really fast, just because, they're stored on disk in the correct order for you already. And because we've done some clever stuff with collation support, it actually works, across multiple languages, across like, capital A's sorted next to lowercase a, because we collated it properly.
So you're trading space for speed. But who cares about space on the card?
Yeah, who cares about space? Like, and even then, like my music, like I've got about 1,300 tracks on my SD card right now, and the database uses about 600K. Like it's nothing.
Okay.
It's tiny because it's stored on disk in a compressed format as well. Someone is asking, can Bluetooth headphones be used? Yes. Yeah, the support in the firmware at the moment is a little bit spotty. It's something I gotta work on before we ship devices to people. But yeah, Bluetooth works.
Through the ESP?
Yeah, with the ESP32. Yeah.
That's one thing with open hardware that it keeps improving after you have it already.
Yeah, and that's sort of our firmware is very rough and ready at the moment. Like it doesn't have a lot of the stuff that Rockbox has, but it's open hardware, and the important thing is we've gotten the fundamentals down. Like we've got a really robust database format. We've double checked that Bluetooth does basically work. There's a couple bugs we need to work out, but nothing's broken. Yeah. Man, it's a shame that I have. You know what? If I. No, it'll be too hard. Yeah.
Okay.
Really nice. Thanks.
Very cool.
I hope people enjoy it. I think it's pretty cool. Apparently, other people think it's cool. More people think that MP3 players are cool than I was expecting, which is great. I think. I don't know. Just when I test using this, it really delights me. Just like I think sometimes we've forgotten that like listening to music on a device that like it can't send you a notification.
Yeah, that won't interrupt you.
Yeah, it won't interrupt you. You can't, when you go and change what track is playing, you can't see that someone sent you a fucking email. Like, it's just nice. It's nice to have a joyful little device. I'm having a nice time with it, and I hope people enjoy it. And I hope I don't make people mad by shipping something that doesn't work properly.
Okay, thank you. And next, I guess, Looney, are you ready?
Yes, I am. So let's rewind more than like 10 years prior to the MP3 players, and we have a mod player here. So I think I showed the panel before. So that's a panel from Apex, and I made a PCB with an ESP32S3, so it supports USB. So I don't have the problem that with the files. So actually, if you connect it to the PC, it shows up as an mass storage device. And what happens there, you can upload mod files on the internal storage. Even so, I don't have like external flash or whatever. It's only a few megabytes, but it's good enough for tracker tracks, Amiga tracks, and yeah, currently. Let me focus. I hide. Okay, yeah. There is like just a JST connector right now for audio, and I just hacked a headphone jack because it doesn't have a case yet. I don't know if it ever receives one. People requested to get like a wooden case because it looks so cool. And yeah, let me try. Okay, when I turn it on, yeah, I don't have a proper deck on there. Focus. Here we go. Yeah, you can see the files, and we can basically like select one, and then it plays the track. It doesn't support all the filters yet, all the mod filters. And we have like we discovered there's a touch functionality, so let me stop it. So we can even play the tracks instruments with the touch. So
it's just a bit. It's on or off.
It's just on off. So it's basically like another button. It's done like that. There are. Can I? Yeah, there are even. Okay, that's running too fast. Obviously. Yeah, but it has only like 1 bit output, so I'm using just Sigma Delta for the audio. It's very noisy when the displays are on. It's not optical. It's capacitive touch. So apparently the things seem to be slightly conductive, like the knobs. And you can see if I touch anything here. Very noisy. Ah! Stop! Ah!
No, you made EDM.
Spilled my tea. Okay. Yeah. So it's a mod tracker. I made a video on that already. It's over a month ago, but we didn't have touch back then, and I believe we didn't even have like the mass storage support yet, which is really cool because that makes stuff really easy. I don't have like to reflash the firmware if I want to track on that. I have another project that I want to show as well, and I hope that works with switching camera because I didn't test that. Can I switch the camera? Let's see. We have. That's not the. Is this the camera? No, it's not the camera. Is this the camera? Yes.
Yes.
Oh, all right. Okay. So these are my like key fob mini consoles that are working with the 10-cent RISC-V chip from WCH. This is the CH32V003. And I made like one device before that people probably saw, which is like a like $1 bomb cost mini console that only has like 2 buttons. But it was quite cool. Even like the battery case fit in the $1 bomb cost, which is nice, and the PCBs. And this time, since the resolution here was only like 6x6 lights. No, I needed to turn down the lights here because the display is so bright. So wait for it. Oh no, I had to order of the devices. Now they're all mixed up. So however, I wanted a higher resolution of the. Okay, I make it. Can I? Yeah. Okay. That's 16 by 15 LEDs, and they are Charlieplex. That's why it's called Megaplex. It's a double-sided board. You can see the traces on the back. So it's quite dense here. No current limiting resistors anywhere because I picked LEDs that are rated up to 3.2 volts. I believe when I picked them, they had still like 3.3 volts in the data sheet and they changed it afterwards or something. I don't know. I was sure I could run them from the 3.3 volts. It has like USB for power, but at that time that I designed it like almost a year ago, I knew there will be some soft USB implementation for the RISC because that is running on 48 megahertz, which is fast enough for soft USB. And Charles Lohr did the library, so we can even program it now over USB. The problem is if you're using Charlieplexing and we have only 18 GPIOs that are usable, actually it's only 16, but you can turn off the reset pin and use it as a GPIO, but then you can't reset anymore. You have to power cycle it to program it. And you can also turn off the programming pin and use it as a GPIO from in like when it's running. So that can be done directly, like changing a register, but the reset pin has to be like that's in the flash flag. So that's checked, I think, on boot up or something. So 16 by 15 LEDs, Charlieplex matrix already requires 16 bits or 16 GPIOs, and I picked 16 because you have the C and D registers that you can write directly with one write operation. So it's really fast to update like a line of the screen, and then you run it 16 times. So you have a complete refresh cycle. And one one update of a screen line takes only 60. I set up the tick interrupt for every 128 cycles. So it's quite fast updating one line, and then 16 times you have like what was it, around 23
it's 23,000 times a second or something.
Yeah. It's super fast. You can run it like with 1 bit with 23,000 frames per second, or in 8-bit like 90 frames per second. So you can run it in 8-bit basically. Let me show it. So like, we want to see it. I don't know which one that is. It's already on. I hope. Yeah. Oh yeah. That's the jump and run, that the buttons are messed up. So that's a problem. But I wanted to show that live. Let me show. I think this is. Oh yeah, that's an 8-bit display, but it's so bright you can't see. Yeah, that it's a rickroll. Yeah. So this is running at 90 frames per second with 8-bit, and what's happening there for this highest for the refresh of the highest significant bit, it's basically the timer delay is simply like way longer than for the lowest significant bit. So you could even like do some gamma correction with the timing, but I didn't do that. I have like a normal gamma correction anyways, like on camera, it's always too bright. So that's the 8-bit, but then let me oh yeah, it's that one. It has like a 5 seconds delay before it boots. Oh yeah, we have sound. I don't know if you can hear that.
Oh, is this from one pin?
Yeah, that's one pin, and it doesn't have an amplifier. That's why it's a little bit. It's not as loud, but yeah, this is my version of Bad Apple. We converted the MIDI, and we converted like almost the full animation. I think it's several thousand frames in like 16 by 15. And I wrote like on stream, I wrote a compression method to be able to fit that. So it's like around 2 bytes per frame. It's a lossy compression, but you can't tell. So
Where's
Is there
that
one
board?
pixel on in the corner all the time?
bitte?
There is one pixel that in the corner that is.
Oh
always...
yeah, that's a death pixel. Yeah, that triggers people, and I love it that people are triggered. This is how you get attention on social media right now.
Engagement.
Engagement.
No, I mean
yeah.
upper left corner. There is one pixel that.
Oh yeah, that's ghosting. You can see if you update just by writing the 2 registers, and you have like the update rate of the registers are quite fast, then the time, like this is you can see basically a shadow of the last row in the first row. You can prevent that by just writing, like turning them all the registers like in read mode, so they don't take any current, so you don't have the LEDs lit up from the other. So you have write 2 registers, you can't write them at the same time. That's why ghosting happens. But I fixed that for a later update. It just takes like another register write to get rid of the ghosting. But in that case, I didn't bother to update that, since it never change a running system, and I have a showable version here. So yeah, it runs in 10 kilobytes. We have several thousand frames of Bad Apple here. And it runs quite fast. I think, it runs at 30 frames per second, the animation. And basically, it doesn't make a difference if you store, like with the compression method, since you only like storing like the difference between the frames, and there is some more things going on. It doesn't like make a big difference if you store like 15 frames per second animation or 30 frames per second. there's like less change if you have a higher frame rate, so you take the frame rate for free, which is really cool. Then that was the first one that I wanted to show. It's a little bit buggy, but it's quite bright. Okay, is this snakes? We have the 5. So that's the only actual working game is snakes here. It has also sound, but it's quite faint. The funny thing is, if you as I told you, we need like 16 pins to use for the display, so we have like 2 GPIOs left, and we have to manage the USB, D+, D-, and 6 buttons and the audio, which is like, how do you do that? For the USB, I have this switch here. It basically switches between the buttons and the sound and the D+ and D-. The sound takes 1 pin, and the buttons take the other pin, like with a resistor ladder and analog read. But I messed that up. That's an actual buzzer, a magnetic buzzer here. So they're quite cool because they're better than the piezo stuff, and they're not very expensive. I think they're like max 14 cents or something.
When it's on, is it just always buzzing, or it's like a speaker?
No, it's like a speaker.
Okay.
They specify like the major frequency, so you could they say it's buzzer, but you can play anything of that. I mean, we can play any frequency. It's quite a good thing, like, because it's also like surface mount. You don't have like to solder anything. You can all this device was done by JSC PCB, and all the parts are from LCSC. So I ordered them. They delivered like that with that one broken pixel. On the back, I have 2 footprints for CR2032s, and the first version of the board, let me show that, has a slight difference. It has even a charging circuit, but that charges quite slowly. Let me show that. 2 footprints for the batteries, because you can use that one, which is more safe. It has like, let's say, the convex hull always touches the plastic parts. And if you have one like that one, which has a lower profile, which you might want to have if you're using a case, that is the plus side of the battery. And you could basically, if you put this in your pocket, like with a key on a key fob keychain, you would short the battery with the ground here of the USB or whatever. So that's why I use that, but you can run it from USB-C, which I'm doing most of the time.
What's the switch on the bottom?
Oh yeah, that's an on-off switch. Yeah, it says even on there, so everything is labeled. But it's quite cool design. But I will switch to a different microcontroller because, the buttons right now, I messed the resistor ladder up. They are floating if they're not pressed, and that's not great. With the jump and run game, you can't use 2 buttons at the same time. The snakes is good enough, but oh well. Yeah, and there is a new microcontroller that someone mentioned. I forgot who on the Discord. That's the basically also, I think this is also RISC. I don't know why it says X. It's the 35. So it costs a few cents more, but it has, it's also slightly bigger, but you can get it as a QFN as well. So if you compare the size, it's not way bigger, so it would fit there. It has like four pins more, and it has native USB and even power delivery if you need that. So I didn't play around with that one yet, but
the USB is dedicated pins. I mean, not in the 4+.
There are in the 4+. I think you can even there are even like multiplex. I'm not sure. really need to check that before I say anything. But yeah, it might be like 2 pins that you can use either for USB or as GPIOs. Something like that. I'm not sure if it's dedicated that you can't use for anything else. But
Did
I
you
want
say the USB was PD compatible?
Yes, it is. Yeah.
Mm.
So it has some power delivery features, but I don't know what's implemented there. You can imagine. Yeah, it's probably not much support yet, but usually WCH has some examples that might work. I don't know. Yeah, I have to try that yet. Yeah, I want to get rid of that switch in the center, so I will get even more space here, and yeah, not switching the 2 remaining pins and keep like the resolution of the matrix. Yeah, that's that.
Gotta love routing Charlie Plex to LEDs.
Yeah, it's quite easy. I mean, if you don't have like the resistors, the current limiting resistor, I think they are somewhere like in between.
I put them all at one end.
Sorry?
I put the current limiting resistors close to the pins on the microcontroller, and then they come off of that. So they're not anywhere near the LEDs.
Okay. Okay, I can maybe I have even the design here. Maybe I share it for a second. Share screen. Okay, let's docs. Here we go. Yeah, so it's a 2-layer board, and yeah, I have the vias on the pads. That's all right. And basically, you can do it by hand, but it's so straightforward. It's just a pattern. So if you check, I can probably not switch directly. No, it won't switch to the schematic. The schematic is also quite simple in that. So when I saw Pat's tool, I immediately thought, oh, I would use that to generate like Charlie Plex matrices.
Yeah. For sure.
Yeah, and that's other than that, it's quite dense, like around the micro, but then that's quite all right. I mean, there's enough space. Yeah, that's all from me, I guess.
Cool.
No question.
Where's the where
Yeah.
like that Apple thing? The where's it stored? Is it on the chip?
On the chip, yeah. The chip has 16 kilobytes, or like almost. No, it's like 19 or something. No, yeah, something like that. But there is some space dedicated to the bootloader, and then you have like 16 kilobytes that you can use, but that's shared between the code and everything, basically.
What's the
Code
bootloader
data.
do? Does it let you program or switch to whatever?
Yeah, so Charles Lohr wrote basically the USB stack, and what it does is when you turn the device on, it tries like to initialize the USB stack.
Is that 5 seconds?
5 seconds, yeah. That's why you have the delay in the beginning. So if there's there's even like a Roter Fruchtzwerg. So Andreas made an update specifically for that device, because you can avoid the 5 seconds if it's switched to the other setting and you don't have a host. It won't wait for the host to do anything, try to connect via it's using human interface device to upload the firmware. It wouldn't wait for anything to connect if the host isn't present. In that case, like if I, sorry?
How's it detecting that? I mean, you're getting power through there anyways, right?
Yeah, you get it's powered on, and then there is like this USB initialization. I don't know the
through the CC
procedure,
line,
but
maybe.
if there is no initialization of the USB, then it doesn't need to wait any
okay,
longer.
the
Something like
enumeration or
that.
whatever. Yeah,
It's just, but in that case, I mean, you connect it, and if it's like the D plus and D minus are not connected, then it doesn't need to wait 5 seconds. That's just a special case. Oh, it pull request has been merged. So yeah, Rota is MVP here. Yeah, that's so in I think it's like 2 kilobytes or 3 kilobytes is like the whole USB stack that is programming, like where you can upload the firmware, and the rest of the 16 kilobytes is for the code. And I really tried like to fit the whole animation, which is a minute long or something, but it wouldn't fit without like a huge quality loss. And at the end, I used 10 kilobytes for, I don't know, I can maybe check how many frames it is, but can see now.
And the programming is like a mass storage. Is that what you said? Or it's a DFU?
No, it's not mass storage. In that case, it's just flashed as an array, C array. the mass storage was in for the other device.
Oh, right. So,
Yeah.
but what does it look like to the computer?
Oh, it's a human interface device. So like
Okay, something that takes data.
keyboard, mouse, stuff like that. Because you can basically you have bidirectional communication.
Serial, basically.
Yeah.
Probably like a USB CDC thing, like a standard serial.
It's
Yeah,
not,
heap serial is actually a bit funny.
yeah, it's more tricky.
It's so weird. It's so
Yeah.
weird.
Yeah, CDC, because I mean, you don't have CDC, I think, in USB 1 or 1.1. There was like, it's not official that it's not officially supported, and some drivers support it or something like that. That's why you either use DFU or human interface devices, and that's basically because you can send data to human interface devices like for force feedback or just the LEDs on your keyboard, and that's how it's used, I think. Oh yeah, browser. That's also cool. Didn't try that yet. Okay, I don't know how many frames it is. Wait, what is it? Oh, here. Maybe I have it. Yeah,
So for
3,000 frames.
For the
4,000.
silk screen pattern, did you
3,000.
use an SVG or just make it yourself on the back?
What?
The silk
For the
screen on the
silk
back.
screen pattern on
Oh,
the back.
yeah. Well, it's so hard with KiCad. So that's just halftone. I just took like halftone things in GIMP. There's like this halftone filter, and then I think I converted it to SVG afterwards, and then imported it in KiCad. It was really a lot of work. I don't know, probably there are cool plugins for that, but I reinvent the wheel. Especially since like your DRM rules, basically they complain whenever like one of the dots intersects with a pad, and then you have like to edit them or delete them by hand to
Ignore
not get any
them.
warnings. I hate that.
Me too. Those warnings, man. The silk screen is touching. Oh, good.
Yeah, nobody cares. No fab house will actually put like silk screen on a pad.
Right. If you are interested, FreeSync has native SVG support.
Oh, nice.
Super easy.
Okay, now I'm done.
There you go.
Okay, thank you very much.
Very cool.
We go to Bradan, who fixed his sound. So
Yeah, I had to. I finally gave up and I rebooted an old machine to get back up and running.
Now with Windows.
the microphone is a bit loud.
Actually, bitluni, you're right. Actually, I had to shut down my back and turn on my old Windows machine. One thing I want to do is I actually want to go and look at Jacqueline's SVG generator, because if people are curious, two Makercasts ago, I think, or maybe 3, I showed my circular touch, and I provided code in C for 3 or 4 different microcontrollers. The smallest being, I think it was an AT Tiny 16, and I've also got it running on an ESP32, and I've got it running on RP2040 and a SAMD21. And I don't use any libraries. I write the code that I publish is direct to the microcontroller, and it's all written in C. And I've done it with 3 pins, and I've done it with 4 pins. But I've always had to, just like Jacqueline was saying, I had to manually create my my layout. So having it be able to be generated as SVG would be really, really cool.
Yeah, that's why we have an SVG generator. I was sitting in KiCad, like tracing the thing, and my partner was there and was just like, no, let me write you some code to do this.
No. I did it manually in Inkscape and then brought it into KiCad, but that's all right. So whenever I'm on Makercast or whenever I'm doing tutorials or anything else, I almost always have a down-facing camera on my desk. And oops, just a second. I don't want to open the window. I want to just simply show the window. Give me a second here.
Hey, Braden, you're a bit on the loud front. I don't know.
Which is odd because normally my microphone is ungodly soft. But anyway, I tend to do a down-facing camera, and I inevitably end up bumping the camera. And so I've come up with many different ways of solving my down-facing camera. But I'm going to be doing workshops at a couple of conferences, and so I needed a down-facing camera solution that was very lightweight and very portable. And so right now I'm actually showing my AVR coding kit, which I also do Charlie plexing. And Bitluni was asking about the current limiting resistors. I packed them all right over here. And that's how I did that one. But I wanted something small and I wanted something portable, and I've made them out of aluminum. I've made them out of all sorts of stuff. I've used clamp versions for my phone and everything else. And so recently I said, well, I need something portable. I'm going to 3D print one. And so this is what it actually looks like. So there's my phone. The great thing about it is I can move this around and the image doesn't change. I can bump this and the image doesn't change. It stays right where it's supposed to be. And it's a top piece, a bottom piece, and then it's got 2, these are identical. And the great thing is you can make them in different sizes for different phones, or this one is set up for video. This is actually great for doing photography, where I want to zoom in. And I designed it in Fusion 360. If people who don't like Fusion 360, you can take that offline. But I did it with parametric, so it makes it real easy to remix this any way you want. And I've started to publish my files not just as STL, because it's really hard to remix or edit in STL. So I provide it as STL, step file, and then of course the original authored Fusion file that you can just simply import and run with it. And so this is what I've been doing quite a bit. And I use this all the time because I'll show you right now. Let me switch back to the transition here. So like I'm actually moving the camera about 8 inches and it doesn't change the look of it at all. It just stays nice and stable.
There's just a hole in the top and then the camera just looks through there?
Yep. So if I take the camera off, I designed it with a hole, which happens to line up very nicely with the ungodly large lens format thing that Apple has gone with their phone, but it makes it really easy. And then it just simply drops back in and it syncs up, and now it's in line and it's ready to go again.
Did you consider to add LED lights to have like more consistent lighting?
I have tried all sorts of lighting solutions, and unless it's way over on the side, and it has to be very far away, it ends up creating, like I'll show you right now, you end up with this problem.
Oh, right. Yeah.
And I find with room lighting, it's not too bad. I mean, I've just got regular room lighting behind me, and it works out pretty well. And for a portable solution, this is really all I want it to be, as simple and lightweight as it possibly could be. I'm going to take this off for a second, and it just.
So yeah, it's just 6 pieces, right? Pop, pop, pop.
Yeah, and they're all just press fit. Of course, my printer is really good at getting the accuracy of press fit. I don't want to break it on the. That'd be my luck. I'd break it right here. Oh, there it goes.
Please do.
Yeah, I know.
We want to see the word border.
But it's just a flat piece at this point, so that's really easy to print. And the same with these side pieces. They're just flat, so they print really easy.
Yeah, I bet you could even laser cut them.
Could you laser cut these? You could if you didn't want to have, like, if you look closely on this one, I don't know if I can get closely and have it work or not. There's a lip right here that gives it stability. You'd lose that lip, but you probably could laser cut a version of this. But when it's all done, it's literally this tiny little pile of parts. So it packs real easy and it works really well. And so that's one of the things that I've 3D printed and I've been using a lot lately. The other one was, as I mentioned, I switched to a Mac and I'm still getting up to speed on it. But one of the things that I found most difficult switching back and forth between my old Windows machine and the Mac was the Mac keyboard and the touchpad. And so I looked around for a keyboard for Windows that was very similar as far as the layout and the spacing of everything. And I found this is actually a keyboard that goes to, what was it? The Lenovo X1 tablet. It's like their tablet. And so it's got a little flexible thing on it. And it's got a magnetic clip and pogo pins at the end. And somebody figured out that the pogo pins are just a standard USB. That's all it is, just USB.
Oh, this is so awesome.
And so what I did was I 3D printed a little piece that has just enough space here for the leatherette kind of flippy piece that the original keyboard had. And it's got a notch right here for where the pogo pins go. And then on the end, it's got just enough space for me to stick a USB-C connector, just hot glues right in there. And the pins for that, if you can just see the little shiny spot right there, the pins come out so I can just run the wiring right in here. And to make it, and I'm afraid I'm going to crash my computer if I do this, but I used magnetic quick release on my USB cable. So I can literally just pull this thing, drop it on my desk, and the magnetic cable just snaps on and I'm ready to go. And like I said, the layout ends up being very close to my MacBook. So I have less of a learning or transition curve when I go between my Windows machine and my Mac. But it was just a matter of coming up with this little 3D printed tray that gives me just the right amount of angle to the bevel. See, it's kind of, there you go. You can kind of see it. It's higher in the back than it is in the front. And so it gives me the perfect list for this. And so that was the first thing that started me down this road of, okay, I'm going to completely organize my life with 3D printing again. So those are done. If somebody can grab from the private chat, I put a link to where I'm putting my design files. I'm making them available as, like I said, STL file, step file, and then the original Fusion 360 file. And you can just, there you go. Thank you very much. You can just grab them and go with them. I put everything out under the MIT open source license. And I'll probably find a few more things I want to do on my desk to get things organized. But the down-facing camera was the first one that really got me going, because I need this for a series of conferences I'll be attending this year. And I want to be able to show off things like I was doing before, where it's just, I put a PCB under it, or I'm trying to demo some piece of electronics, and it's really nice to have it on it. If I bump the thing, the camera angle never changes. It's always lined up.
Yeah, it's a simple thing, but it's convenient.
Yeah, like I said, I wanted something that was very small and lightweight and would travel very well, and so that's the sum total of it right there. That's the travel size of it.
Like a book, basically.
So that's all I have.
Okay. I
Very
think
cool.
there are no more questions.
Is that a space mouse?
Yes, I've that's my second or third one.
What do you use it with?
Under Windows, I only used it originally with Fusion 360, and it's a godsend when doing three-dimensional CAD work. Under Windows, it now works with KiCad. Under the Mac, it's kind of buggy still. But
Yeah, I'd set it up for KiCad, like homebrew style, and it was okay, but I never.
under
Now they
Windows,
have the
under
core.
Windows, it's great. And one of the things that I do is if I want to show off a design I'm working on, I will. I go into the 3D viewer, and I start screen recording that window, and then with the mouse, I can do a really nice animation of the object, sort of spinning around and coming up. And I did one of a
You sold me on that.
Yeah, I did one of a PC of my board going up and then flying and then doing a reverse like a spaceship. And so that's all really easy to do. I mean, that's kind of a gimmick for it. But the biggest reason I use it is for CAD work. It's invaluable for doing CAD work.
Yeah.
The mouse control in the 3D viewer is so awkward. I try to record for my videos as well, like, flip it like that, and I want to look at that.
No,
it's not possible.
Oh, you have to use
You're always in the gimbal lock somewhere.
There's a flip button that's really fucking useful. It took me a while to discover it.
But it's
but I'm sold on that 3D mouse. I need a 3D mouse now.
Yeah.
Don't buy them new. Do not buy them new.
eBay.
Preview of 8.
There are the simpler ones. The smaller ones.
I'm avoiding 8 because right now I'm running into bugs between Windows.
Oh yeah, you can wait till it's out of
between 709 and Mac 710. I've got a board that works great on Windows and 709, and generates 120 design rule failures in 710 on Mac.
Well, send the Gerbers from the other one, yeah.
Yeah, so I have to keep
Pentium bug.
Yeah, that's the opposite. It's an Apple Silicon bug or something. I don't know.
Yeah, the float division is broken. Like it was 20 years ago. What was it on the Pentium?
But yeah, so
bug, I guess.
But eBay you can pick up, 2 and 3 generation ago versions of the Space Mouse, and they're $30 or $40, and they're great. I just sent my previous one up to a group up in DC because they wanted to play with it. They'd never seen one, never used one. But they're awesome for, like I said, for CAD mostly, and for KiCad on Windows, it's really good. And I'm hoping by 8 they'll get it kind of nailed down on.
Yeah, I'm going to try it again for sure
on Mac.
Okay. Are we ready for the quiz now?
Oh God,
quiz!
Oh God, there's a quiz.
Yay.
The quiz.
Okay, so
Everyone.
So this is a bit experimental. So excuse me if it doesn't work the way.
If it doesn't work, it's because Disciple refused to use ChatGPT.
Oh my God. So basically, we are going to be guessing the music, where the music comes from. I know it comes from the speaker, but the idea is that this is 9 different examples of music from computer games.
Oh God! If they're from computer games, I'm going to be completely lost.
Do we write it down and then compare later, or do we shout?
No, the idea is if on the left. So I mean, people on YouTube will have to keep track of their own guesses by themselves, of course. But people in the stream, you can switch to the private chat on the left.
Okay.
I see. You're
And
keeping it
I
real, huh?
recommend typing stop in there and not pressing enter. And as soon, not pressing enter.
Oh,
Don't
so
do
when
it, I
we're
just
done,
do-
we post the whole list.
No,
Oh, it's a buzzer.
I will play the music, and as soon as you think you recognize the music, you press enter.
Why don't we just type and the first one that wrote the answer is right?
No, because that makes fast typer.
Oh yeah, true. Yeah, I'm a slow typer. I use two fingers for typing.
So basically, you press enter, and then I see stop. I pause the music.
Does that work?
All right.
We have to
And
put something,
in
otherwise
the
nothing comes
order
up.
in which I see those things in the chat, I ask people to give me their guess. And if you guess wrong, you lose your chance for that song.
For the round.
So
Okay.
you only get one guess per song. And the first person that guesses gets a point.
Oh, it's
That's
elimination
basically
time.
it. I'm not sure how well this is going to work, but let's see. The games are mostly things I already had on my disk, so it's a kind of a random selection.
I hope
But
they're
I'm
really
sure
old.
everybody will recognize at least a few of them, so can try. The first one is pretty simple, and it takes a long time to start. So okay, type
Super
your
Mario.
start in the chat now and put your hand on the enter, and I'm going to start
I'm
playing.
so ready. This is gonna go from indecipherable to extremely obvious in about a millisecond, I know.
Ah, shit! Mo.
Okay, so Moritz goes first. What's your... Yes, this is Kobaleshniki.
I knew that this one would be part of it.
Yeah, of course. It has to be in the... Okay, so you have 1 point. Next. Type your... I should... Okay, I will make a cut off here.
But I guess there are also online buzzer programs, I think.
Yeah, I didn't want to, complicate
We could
it.
just buzz.
And,
This is better because
this
when I
also
don't
gives
win, I
me
can complain
the
about
order,
lag.
so-
Copilot suggested Super Mario Brothers.
Copilot just being like, "What's a video game?"
No!
I'm thinking this might be Super Mario Brothers. I'm thinking Copilot had it here actually.
Yes, you get a point.
Oh, what?
My hand wasn't on the buzzer.
I'm on Bluetooth headphones. I have a delay of
Oh,
100
Oh,
no.
see, you
seconds.
gotta get
So
wired.
sad.
The latency's too big.
That's all right. The last video game I played, I think, was 1983. So
Sorry. I mean, those also appear on TV or whatever. So maybe. you've
What is
seen
the
them
music to
somewhere.
Space Invaders?
that's what I was trying to figure out. I think that was like the last video game I played.
Oh,
Okay, number 3. Ready? Go.
Oh, this is Portal.
Ah, yeah.
Yeah.
I was
The
completely
Pirate
wrong.
song or something.
I guess Descent, but I don't think so.
No, Jacqueline was correct. This is
Oh,
Portal,
yeah.
Portal 2.
Pat, you didn't.
Gotta get
write
on my
stuff.
gaming level.
Number 4. Ready? Go.
Angry Birds.
Correct.
I'm going to get
Angry
crushed.
Birds sounds like that.
Come on, man. I need Doom and Mist.
Yeah.
I wouldn't even recognize music from Doom.
I don't think
Oh,
I'd
you
rec-
would. You would.
Heretic
you would.
had
Oh,
a-
you would.
amazing
You would.
soundtrack.
Number 5.
This is.
It kind of goes.
Okay, psychogenic.
Who was first?
You.
You were first.
Oh, I'm guessing Luigi's Haunted Mansion or something like that.
No.
No.
Jacqueline?
I'm thinking it's like a Donkey Kong 64. It sounds like a Rareware platformer. That's the best I've got.
Anybody else has an idea, or should I play it more or
More.
More.
more?
Something magical.
Okay, Looney?
I would say Monkey Island. No.
No.
But we get Monkey Island, judging of your face right now. Okay.
I don't confirm and I don't.
Wait, Moritz gets the point for free now.
Sorry?
Moritz gets the points for free now, or does
No.
no,
I guess
no,
not.
you have to recognize it. Okay.
Braden
Let's
also
do it.
didn't-
Let's do it.
Okay, I'm going to just forfeit it.
Why do you have Professor Layton or something? I don't know.
No, it's the World of Goo.
Oh.
It's this game where you build bridges out of little black things with
I
eyes.
actually played that game.
Okay.
Wow.
I don't know that game.
I just had it on my disc, so
Okay.
Wait, what was it?
World of Goo.
Oh.
It's these different kind of goops that you know. These ones stick together. These ones do
Once
whatever.
again, why does that game sound like that?
It's yeah. I don't.
it's really dark. Like if from the music point of view, it's really, and the story of it is really like you have this giga corporation. That
A kind
is
of world of
using
goo,
those-
as it were.
Yeah, it's really. Anyways, next one. Ready? Go.
So ready.
Okay,
That would
Jacqueline?
be Chrono Trigger.
Correct.
That's
Oh,
the
wow.
Millennium Fair music from the start of the game.
Let me. You get a point.
I don't need to say which specific track it is, but it is a flex if I do.
You go ahead.
It was the Millennium Fair one, right?
Oh, of course. Yeah.
Yeah.
Okay, number 7. Ready? Go. Okay, I see we have no takers, so I'm not going to play
Sounds
it
like
at all.
that.
Animal
That game with the
Crossing.
islands there and Nintendo.
Stardew
Everybody.
Valley or Plants
It's
vs.
vaguely
Zombies?
familiar. What is it?
So this is a short hike. This is a pretty recent game, like 3 years.
Ah.
ago.
Yeah. So the ironic thing is Shazam actually got that right.
Oh, I see.
Cheater.
Well, I told you I haven't played any video games. It's like so. I stuck it up to my ear, and the thing is, I didn't know the name of the game. It came up with the name of the song, but not the name of the game. So I'm going, well, it doesn't do me any good.
Okay, so let's go to the number 8. Ready? Go.
Understand the concept of love. Understand the concept of love. Understand.
Yeah. Okay.
Is
I
it by
see
any chance
from
a
your
video
face
game
that-
called The Concept of Love?
Right.
Yeah.
That's the title of the song, correct? But we need the
Well,
title.
it's a Sega game. I know that much.
Yes, correct.
You
It's
know this
called
because
Jet
Sega
Set
games are
Radio
often about
Future.
love.
Sonic the Hedgehog.
It's a Sega game. Right?
No, it's a Jet Set Radio Future, a game
Oh, of course it is.
where you have rocket rollerblades and you are spraying walls.
Ah, nice.
It has really amazing music. I
Yeah.
I'm understanding.
Yeah. Exactly. So.
I mean, the rest of it's like it's of course music is by the Japanese composer, but he
Hideki.
American music and was inspired to create this. Anyways, the last one. That should be
Last chance to
a
get a
bit
point.
easier. Ready?
Atomic gave up.
Okay.
That's
Okay.
a Zelda-ass motif if ever I heard one.
Of course. Yes. It is the Legend of Zelda, the main theme.
I would expect Ocarina of Time or something like.
It takes time to develop. But yeah, I have a symphonic orchestra version.
But nice
Anyways.
player you built there. Nice
yeah.
quiz player.
That's all I have, and I suppose either Jacqueline or Moritz.
Not me.
Yeah, I didn't get that
I
point
didn't-
either. So.
Back of your
Jacqueline
point.
definitely got more right, I guess.
This is what happens when you invite a gamer into your quiz.
This is what
What can I
happens.
say?
Catching up for last week.
Nice take on the new form of quiz. We didn't have that one
Yeah.
before. That's cool.
Yeah, I mean we could do this with movie music as well.
Oh yeah, then I beat you.
Not if I get to choose the movies.
All Polish black
Maybe I
and white.
still beat you.
Anyways, that's that.
0 out of 9 Peter Stimple.
How did?
Me
Yeah,
too.
that's it. How's the chat?
Big talk from.
I think you would have gotten the last one if it played longer. I think there's a drop at one point and then everyone will know what it is.
Yeah, and it's a bit bad that only one person gets a point, right? So there are very few points to go around, actually.
That
Well, like I
explains
said, you were pretty
zero.
much guaranteed it was going to end up with 0.
Yeah, boy. But my gaming experience is it dates a little bit.
Yeah. No, I went to university and everybody on my floor said, "Well, you've got a computer. What games are on it?" And I went, "Games."
Next
Why
time
would
we
I have
try
games
that
on a
with
computer?
animal sounds. Like
So, yeah.
recognize animal sounds or something.
There we go. I might have a chance at that.
Yeah, or you take the audio, compress it a lot, and then remove the compression as it goes along, so it gets like these
Oh,
pixel
an
art quizzes
unveil.
where it's like pixelated first and then
Oh
Yeah.
yeah.
Nice.
By the way, I did fix my database woes. It's all working now. Look,
Right,
scroll
let me-
through
Oh,
Yeah.
everything.
How are Japanese characters?
Yeah,
sorted?
you-
Like,
you're
Oh,
spelling
yeah,
hiragana,
yeah, yeah.
katakana.
The Unicode.
Yeah, because we bundle a little pixel font that has like every character you could ever want. Because I wanted it to work, you know.
I love circular touch wheels. They're just such a cool design.
They're so fun, and we have little directional shortcuts as well, so we can go back really easy.
Oh, and by the way, the user interface is programmed in Lua.
Yeah, it's Lua. I love Lua. I'm a big Lua head. Happy days.
The ergonomics of
Basically,
that.
it's the same like DaVinci Resolve. That's
Oh.
also Lua.
I got that working.
All right, Atomic is remind me of something. So if you want to be on the Makercast, then contact one of us. We can invite you to the Discord, and you can. It happens on every first Sunday of the month, and we can have you with your projects in here. It doesn't have to be next month. Can be in a few months from now. You can join the Discord earlier anyways. There are some discussions in there about videos on YouTube, maker videos and stuff like that. So might be interesting, especially if you have a YouTube channel. Makercast used to perambulate between different channels. Now we have a dedicated channel for it, so it's a bit different, but still I think it's a very nice way of letting people know that you exist and you have project on YouTube to show, and Anyways, this is all I have. I'm not showing my projects today.
Host privilege.
Sorry?
Host's privilege.
Yeah, well, I could, but my projects tend to be monotonous. I keep doing the same thing over and over until it's nice.
Perfected is what you mean.
Yeah, something like that. Anyways, thank you everybody, and see you next month on the next Makercast. Goodbye.
Very
Cool.
cool.
Thanks for
everyone.
having me on.
Game.
See you
Bye-bye.
later.
To the audience.
Farewell.